Okay. This is, I will start once again from biasing. So biasing means, so common emitter configuration. So input current is IB and input voltage is VBE. So this is IB. Capital IB means is DC current. We are talking about DC current. Biasing with relates the DC values of current and voltages. This is VBE, and the curve is like this, right? Input curve is like this. So just like Riot curve. We have a fixed IB and there is a fixed VBE. So this is VBEQ, VBEQ, quiescent point of input voltage, and this is quiescent point of IBQ, that is input voltage. Similarly, we have the quiescent point of this one, output voltage, and this one is quiescent point or the current of the output current, right? IC is output current and VC is output voltage. So that we are fixing these Q values, that is Q point, biasing in such a way that the amplifier always in the active region. So this region is called, you might be knowing the input and output characteristics of a common emitter configuration. So it is like this. So this is base current, different value of base current, and like this. So this region is called the saturation region. This region is called the saturation, and this region, no current region, is called the cutoff region. So proper amplification, that is undistorted amplification of input signal, the amplifier should work in the active region. So in order to work the transistor in the active region, we are fixing this bias point. So biasing input bias current, input bias voltage, output bias current, and output bias voltage. That all are Q point. Q point means quiescent. Quiescent means silent point. So that will not be unaffected with the unaffected, that is silent point. Okay, so we are fixing, that is called biasing, that already we studied. So this is a single stage RC coupled amplifier. This is a definite question for this KTU. So this is exactly equal to the voltage divider biasing circuit, the extension of voltage divider biasing circuit I am drawing here. So we have the transistor, so emitter, and this collector resistance, we have the supply voltage, and then this point is grounded, and we have extra this capacitor here and this capacitor here, and we are one capacitor, and then we are applying the input voltage. So this is always there. This signal input that is to be amplified is connected to the base of the circuit, and we add three capacitors here. Here also one capacitor there, here exactly. So this is called the C1, CC1, and this is called CC2, and this is called CE. So we know that RE is for thermal stability. In order to avoid thermal runaway, we studied already in the last class. RE is to reduce thermal runaway. Otherwise, if RE is not there, as beta is a function of temperature, IC increases, junction temperature increases, so that again beta increases, IC increases. So the transistor is burned out finally. If RE is there, this voltage is equal to this voltage is equal to this voltage plus this voltage. So IC increases, beta increases means IC increases, so IE also increases, IERE drop increases, so VB decreases. So VB decreases means IB decreases, so IC decreases. So any increase in IC because of temperature rise, it is compensated by the decrease in IB. So that's why we are using RE, already studied. So what I am trying to say is, we have two capacitors here, coupling capacitor. Coupling capacitor is, first function is blocking DC. Blocking DC. So DC, suppose any DC is coming here, so that will change, alter the biasing of this base current, base voltage, output current or output voltage. So there will be distortion in the amplifier. So in order to avoid that, we are using this coupling capacitor, input coupling capacitor and output coupling capacitor. Output coupling capacitor means, suppose we are cascading the amplifier. That means output of one amplifier is connected to input of another amplifier. So what we are doing is, so this is 1 millivolt, and this is gain is equal to 10. We are getting 10 millivolt here, and here it is 100. So what you are getting 100 milliwatt, 1000 milliwatt here. So one amplifier may not be giving enough amplification. So our requirement is 1000 milliwatt and input is 1 milliwatt and gain is 10 and 100. Then output of this amplifier is connected to the input of this amplifier. So no DC should pass to the an input of second stage. That's why we are using coupling capacitor, and we are using another capacitor called emitter bypass capacitor. Emitter bypass capacitor. Emitter bypass capacitor. So emitter bypass capacitor means here we have capital I, small e, that is both AC current and DC current passing through this one. This RE is, as I have told, so this voltage is equal to this voltage plus this voltage. So RE is common to both input side and output voltage. If AC current is passing through this one, that will reduce the gain of the amplifier. So in order to avoid that, we are bypassing this AC current. AC current, that is small I, is passing through this one, so that the reactance of capacitance XCE is much less than RE. So that AC current will bypass through this one. So that is the moon 3 function, and R1 and R2 are biasing resistors. RC is RL, or RC is load resistance across which we are taking the output, and RE is the thermal stability capacitor. So what is output? Output voltage is equal to, we can write the KVL. So VCC is equal to ICRC plus VCE. So this voltage, this total voltage is equal to, this total voltage is equal to this voltage plus this voltage. Okay. So after so what is VC? VC is VO. VO is equal to VCC minus ICRC. So after passing through the coupling capacitor, what you are getting? Minus ICRC. So minus sign represent there is a phase difference of 190-degree between input and output. I have shown here, this is like this. This is amplified signal is 190-degree phase difference. Now we are going to study the frequency response of the transistor amplifier. Frequency response means gain in dB versus frequency. So this is frequency as a gain dB. So three regions are there: low frequency region, mid frequency region, and high frequency region. So low frequency region, the gain is decreased because of coupling capacitor. So the gain decreases. Gain decreases because of coupling capacitor. Coupling capacitor reactance is equal to Xc is equal to 1 by 2 pi F into C. So low frequency, the reactance will be very high, so that the input signal will not be connected to the base of the transistor. So that's why gain is decreased. So the mid frequency region gain is constant, and high frequency region, you know that there is Miller capacitance. So Miller capacitance is between the collector and the base. So this will appear. So frequency increases means the reactance decreases, right? So reactance decreases means that this capacitance become a short circuit between output and input. So there is a feedback from output to input. So the gain decreases. So the 3 dB down. So maximum gain by 3 dB. Here we are collecting this one. This is a lower cutoff frequency, and this is upper cutoff frequency. The difference between them is the bandwidth. Okay, thank you so much.